Now, let us study the concept map. Motion. Motion is of different types with different concepts. Distance. Length of the actual path covered is distance. It has no direction. The SI unit is meter, CGS unit is centimeter. Displacement. Displacement is change in position in a given direction. SI unit is meter, CGS unit centimeter. Speed. Distance covered per unit time. No direction. SI unit meters per second, CGS unit meters per second. Velocity. Displacement per unit time has direction. SI unit meters per second, CGS unit centimeters per second. Acceleration. Rate of change of velocity with respect to time and direction and has direction. SI unit meters per second square and CGS unit centimeters per second square. Now, uniform motion. Uniform speed, linear motion with constant speed and circular motion with constant speed. Third type, equations of motion when the acceleration is uniform and motion is in a straight line. So the first equation is V is equal to U plus AT. Then we have the three equations for displacement or distance, you can say ut plus half AT square, S is equal to U plus V upon 2 into T, S is equal to Vt minus half AT square, and here we have V square is equal to U square plus 2AS. Then let us see what the concept of force says. Force is rate of change of momentum. Force is equal to m into a, that is mass into acceleration. SI unit is Newton and CGS unit is dyne. Balanced forces. No acceleration of the body, may cause rotation of the body and may produce a change in the shape and size of the body. Newton's laws of motion. First law, velocity constant if the net force is 0 explains inertia. Second law, rate of change of momentum is proportional to the net force. Third law, action and reaction equal in magnitude and opposite in direction, and it is instantaneous. Now let us continue with the exercise. So the first question, match the following first column with the appropriate entries in the second and third columns and remake the table. So first one, negative acceleration. Column 2, the velocity of the object increases, and column 3, a vehicle moving with a velocity of 10 meters per second stops after 5 seconds. Second, positive acceleration. The velocity of the object increases. Third column, a car initially at rest reaches a velocity of 15 kilometers per hour in 10 seconds. Third, zero acceleration. The velocity of the object remains constant and a vehicle is moving with a velocity of 25 meters per second. Second question, clarify the differences. A, distance and displacement. I have shown you in the slides very well the differences, so you can take down from there. B question, uniform and non-uniform motion. On page number 4 you can see this. You can write the definitions and examples over there. Now let us go to the next page of the exercise. Now first let us solve, complete the sentences and explain them. The first one, A, the minimum distance between the start and the finish points of the motion of an object is called the displacement of the object. So you have to explain displacement here. B, deceleration is negative acceleration. So explain negative acceleration. C, when an object is in uniform motion, uniform circular motion, its direction changes at every point. So explain here how the direction changes. D, during collision, total momentum remains constant. So explain this total momentum. E, the working of a rocket depends on Newton's third law of motion. So explain the third law. Now let us go to give scientific reasons. First one, A, when an object falls freely to the ground, its acceleration is uniform. So here I have given you the answers for the give reasons. B, you can take a screenshot of it later. B, even though the magnitudes of the action force and reaction force are equal and their directions are opposite, the effects do not get cancelled. C, it is easier to stop a tennis ball as compared to a cricket ball when both are traveling with the same velocity. D, the velocity of an object at rest is considered to be uniform. So I'll pause here. You can take a screenshot of it. Okay, now let us go to the next question. Take 5 examples from your surroundings and give explanation based on Newton's laws of motion. So in the next slide, you can see I have given here the 5 examples. You can just take a screenshot of it. I'll just wait for some time. Okay, now let us continue with the exercise. Let us see, complete the following table. Now in this table, U is given, A is given, T is given, and the formulas are given. In some places, some are missing. So you don't have to just fill in the blanks. You have to solve it. So here, you can take a screenshot of this, but I will explain to you first how do you do this. Now first, here the first problem, U is equal to 2, A is equal to 4, T is equal to 3, and V we have to find out. So V is equal to U plus AT. So in this formula, we have to substitute the values. So V is equal to 2 plus 4 into 3, that is equal to 2 plus 12, that is equal to 14 meters per second. Next, the fourth problem here. U is given to be 7, A we have to find out, T is going to be 4, S is going to be 92. So substituting in the equation, S is equal to UT plus half AT square. 92 is equal to 7 into 4 plus half into A into 4 into 4. So after you solve this, you get 92 minus 28 is equal to 8A. So 64 is equal to 8A. 64 upon 8 is equal to A. So A is equal to 8. So this is the way you are going to solve and then write the answers. Sixth example here. U is given, you have to find out. A is given to be 5. S is going to be 8.4 and V square is equal to 10. So substitute in the equation, V square is equal to U square plus 2AS. So 10 square is equal to U square plus 2 into 5 into 8.4. So 100 is equal to U square plus 10 into 8.4. 100 is equal to U square plus 84. 100 minus 84 is U square. So 16 is equal to U square. So 4 is equal to U. So you can take a screenshot of the same. I will wait for some time. Now, let us continue with the 7th question. Solve the following examples. So, here I have solved all the problems for you. So, you can just take screenshots and study them. I hope you will be able to understand them. So, with this we finish our lesson. Write the exercise in your notebook. Complete it. Draw the diagrams wherever necessary. The graphs and derive the equations. Practice a lot. And you need to read the lesson many times to understand it properly, and it will be useful for you in your future because this is very important lesson. Thank you.